my name is Daryl and this is Programming in Any Language. We're working with C# right now, but the principles are the same in all languages. Master these principles and you can jump to any language quickly. Today we're going to look at the concept of numeric variables. Back in my COBOL days, we could create two types of variables, alphanumeric and numeric. Alphanumeric variables contain anything that you weren't going to use in mathematical calculations. Name, address, city, state, zip code, they all became alphanumeric variables in COBOL. Phone numbers and zip codes contain numbers, but you never did any math on them, so it made sense to declare them as alphanumeric variables. Today we call them string variables. Numeric variables were reserved for data used in calculations, plain and simple. But when those numeric variables are to be displayed on a screen or on a printer, they need to be converted to alphanumeric. Why? It's because of the way numeric variables are stored in memory. Today, as I mentioned, we refer to alphanumeric data as string variables. Numeric variables today, however, come in a variety of sizes and flavors. This makes it a little harder for the new programmer at first, but in the long run, it makes sense and you'll understand it. Let's take a little peek at what I mean. We're all familiar with the string data type. It's basically a series of Unicode characters. We've been dealing with that for a while. It typically uses 2 bytes being Unicode. The first byte, of course, is all zeros, and the second byte is got your ASCII code in it. Unless, of course, you're working with a foreign language or something of that nature, then you might be using something in the Unicode where something's there. But it does carry it along, so it's 2 bytes long for every character you've got displayed. So it can be quite long if you have a sentence or you have my name in it, for example. The next thing you're looking at here is the 32-bit signed integer. This is a common one we use all the time. It's basically used as a counter, whatever. And notice you can go from 2,147,483,647 all the way to a negative, 2 billion. And so forth down the line. So it's not a bad number to use. The 32-bit signed integer is what I would typically use. That's 4 bytes. It's going to use 4 bytes. If you have the number 1 stored there, the number 10 stored there, the number 32,000 there, it's going to store 4 bytes each time. When you display it in as a string, it's different. So that's there. So integers and strings were there along with a wide variety of other data types. And we'll examine those down the road. But right now, the integer and the string will help us to understand why we need different data types. The thing to understand is that if we are going to display any data to the user, it has to be in the format of a string. If we're going to use any math, the data is going to have to be in the form of a numeric data type. But once calculated, the results or answer needs to be converted back to a string so the user can read it. What you're looking at here is a simulator between string and integer data types. I'm going to use this to show you how you convert one to the other and why you have to convert one to the other. Up here you're looking at what would contain an integer. It consists of 4 bytes. And as you can remember from looking at our ASCII code before, that the switches are sitting here. There's a value of 1, 2, 4, 8, 16, 32, and so on the line, all the way up to this 1,000,000,007,000,000, whatever it is. And a negative sign coming up there. So this is actually how an integer is stored. It's got a negative indicator here, and then 31 bits represent the integer itself when it's being used in here. And in here we have a series of memory here that would contain bytes that we're actually having. That were actually exist in our number. Let's kind of give this a simulation, and by entering a string, for example. If I enter the number 1, for example, it's going to end up being 1 byte. Unicode 2 bytes, but for our purposes right here, it's 1 byte, and this is the way it's displayed. It's got a couple switches on, switch down here showing us the number 1 in ASCII. Now, in order to use this in math, we actually have to convert it to a 1 as an integer, and by doing that, we'd be using a parse command. In C#, parse does that for us. It will actually take it and convert it to an integer or a double, depending on the data type we want, but in this case, an integer. So we'll click on this parse byte. And what it does, it turns on this 1 switch, and now we have all 4 bytes being used to display the number 1, to use the number 1 in math. Let's clear that, and let's try entering a -1. If I add a -1, for example, and parse that, it throws on this switch, which is the negative indicator, plus the 1. And now we see 4 bytes being used again for the number 1. In all cases, no matter what number you key in as a string variable, it's always going to be reduced to 4 bytes for an integer. We'll show that once again with a larger number. Let's try 34,678. This is going to use 5 bytes right here, but when we parse it, it goes up here and it controls, it actually switches these switches right here. And now this number, it represents 34,678 as an integer. And this number could then be used to add to another integer, giving us a total. Or it could be divided by something, depending on what you want, what you're using it. But the thing is, it can be used in math. Now, let's kind of clear this off and let's kind of build that number again and kind of just use switches here to turn it on. I'm not sure what this number is right now, but we're just going to throw something out there. And this number now has been calculated in memory by the machine, by our program. But we want to display it on the screen. In order to do that, we need to use a toString method, which converts it from the integer data type down into ASCII characters that we can display on the screen. By clicking on this, it'll convert that, and we get 36,377 is what this happened to turn out to be. We'll clear that again, and let's kind of give us the same number. Let's make it a larger number, for example, and put a couple things in. Let's do one more thing. Let's turn on the negative indicator. Let's say we ended up with a negative number being calculated in memory. Again, we want to be able to display this on the screen someplace. So we need to do is a toString method. That's going to do that for us, and we'll click on it, and bang, the negative number goes in here, and 4197898 is our answer. 1, 2, 3, 4, 5, 6, 7, 8, 9 bytes used to represent that number on our screen or on our printer or wherever we're going to display it. Yet still only 4 as a piece of memory for the integer data type. So basically, an integer will always take up 4 bytes of memory. At least the standard integer will. The number of bytes needed to display that integer will vary. Let's go ahead and clear it, and let's go ahead and turn on them all. In fact, let's make it a negative number and turn on the maximum size negative number we can possibly have inside an integer data type and see what it displays as by turning all these guys on. Takes a few minutes. I should have built a button here that would do this for me, but that's okay. This is working just fine. We've got them all turned on. Now let's do a toString method and bring it down here, and we end up with a negative 2,147,483,647. That's the lowest possible number you can contain in an integer. The positive version of that would be one less, 2,147,483,647, using less bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bytes to actually store that. So the parse method will convert the integer to a string. The toString method will convert the string to an integer. We'll see some examples of that in code. But that's how this works. This is what data types are all about, how you switch back and forth from the others. In order to do math on them, you need to convert them into a data type that's numeric friendly.
Hopefully the simulator gives you an idea as to how C# and other languages handle the numeric variables. Now let's take a look at a program example to demonstrate how this works when we actually program in C#.
Okay, this is going to be a very short example of how to enter two numbers into a C# program and add them together and then display the results. I'm going to do so basically by using a label as my output, which I'll place down here, and I'll format that thing in a minute. And two text boxes. I'll bring one up here and lay it in over here, and then I'll lay another one, make a copy of it in a moment, and pop it. And let's go ahead and change the properties on these things so we can see them very easily, though. And just jump in here and change the font to, let's say, a bold and say a 10. And that way I can make a copy of it real quickly and get those same properties in this one as well. So now I've got two. Now what I want to do is I want to create a label down here where I'm going to put in the answer. So let's go ahead and do that. We'll change this thing to a, take auto size off of it, and we'll give it a background back on style of say a fixed 3D. So we've got it in place. And I'll take all three of these things and center them. Align their centers, and then let's send them around the form right away. Okay, that looks pretty good. And we're going to need a button down here to do, let's get 2 buttons. One is going to be compute. And the other one, first of all, let's change the fonts on this thing so we can save us a little bit of time on changing that. I want to create this thing as also a bold at a size 10. And we'll make that a little bit larger so it fits the wording on here. Good. Okay, great. And pop it in here. Easy to make mistakes in programming. You'll do it all the time. And now let's change this to exit. But you learn something by your mistakes, so you learn that it can do things like that. Okay, so we've got it sitting here. I need to give these things all names. So this is going to become my button exit. BTN-EXIT. Use Hungarian notation on this thing. This will be button compute. BTN compute. I'm going to have a text in one. TXT input 1 and TXT input 2, and I'm going to have myself something called label out, LBLOUT, and leave it at that. So that's my code. That's what I actually want to create as I'm doing this type of thing right here. And what I'm going to do right now is I'm going to go ahead and enter some code in there. I'm going to go to the exit button right away because that was the easiest one to program. So I'll just go in there and create my close form, and we'll do this dot close. It does that very nicely. Cool. Okay, great. Then I'm going to take my button here and my compute button, and I'm going to go ahead and say that I need some variables in here. So I'm going to say that my integer int number 1 int number 1. I need to actually specify that thing, so I'm going to specify it like that without anything else. Int number 2, it has, so that's my 2 variables, and I'm going to actually mark down here input variables. Input variables. And then I'm going to go down here and I'm going to say I need to bring those things in. So read user input. And I'm going to say that int number 1 is equal to int.parse txt input 1.text. So what it's doing, it's basically taking the property of the text input file, parsing it into an integer, that's why we say int right here, and putting it inside this variable. And I'm going to say int number 2 is equal to text input number 2 right there. So that's it. Then I'm going to say let's calculate sum. And I'm going to say that I need another variable is what I really need here. So I'm going to create another variable called int output. And I'm going to say that int output is equal to int number 1 plus int number 2. And put a semicolon right after that thing. And so that goes there. So that'll calculate it. Now I need to display that output. So I'm going to go ahead and say display output. Now in order to do this, I need to put it inside a label. So if I try to just put it into the label straight, it's not going to work. I need to actually do a two string thing. So I'm going to say my LBL output LB out dot text is going to be equal to int output bang. And a set of parentheses around it, and that should do it there completely. I'm going to run, and I'll explain this code for you very quickly. Let's just go ahead and save it. And I'll do a start. The program comes up. Not a lot of information on here. I certainly should, if you're going to do a good job, you want to actually tell people what to put in. But I'm putting the number 10 right in here. I'm going to tab down and put in the number 12 here, and I should get a 24. So I'm going to say compute. And out comes 22. I'm sorry, 10 plus 12 is 22. It does come out right. I didn't format this guy right either, but it does do that. I can easily put in something else like 3, 4, 9, and 1, 2, 3, 4, 5, 6, and compute that, and we get a large number of 1, 2, 3, 805. 1, 2, 3, 805. Yeah, that's about right. Looks like it's about right. That I can get out of the program. So that works out very, very well. Let's go ahead and put a breakpoint on this thing right away. And let's watch what happens when I actually run it. I'm going to go ahead and start the program. And we're going to get our form to come up. I'm also going to bring in a watch box over here on the side here. And I'm going to go ahead and add watches. I'll show you how to do all this kind of stuff later when we get right down to it. It is running. Here it is. There we go. I need to actually put in something. I'll put in my 23, and I'll put in 56, and I'll say compute, and that's going to stop it right now. So now it's sitting in there. Now I can go ahead and look at these things. So I'm going to add this watch here. I'm going to add this watch, and I'm going to add the input-output watch. And you can see they're all valued at nothing right now. That's all we're seeing right now is 0 in here. But it's got the numbers sitting there. As I watch this thing, I can step through my program one line at a time. I'll be using the F11 key. And I'll do that, and it's going to pop through and accepts these variables, establish them. The first thing it does, it goes out and grabs the input from the text box and parses it. So as soon as it does that, it brings in a 23 into the int number. So this value is now sitting as an integer in int number 1. I'll press F11 again, and it'll pass through and get this second text box and bring in 56 into this integer. You can also take a look at it by just highlighting over it. You can see that it kind of highlights 23. It kind of shows 56 and so on down the line. Then you can see, I can highlight over here too now, 23 and 56, and nothing in output. That's still 0. But as soon as I hit F11, that changes. And we now see the number 79 sitting in there. So it's going to take that 79, which is sitting out here, convert it to string so it can be displayed as label output. When enter on this thing, or F11, go through this process, and we should see the form pop up, and there's our 79 again. Should have made this bold. I should have done that. But that's in essence what we do. We'll look at more about math in the next video, but I just wanted to get you this concept down of how you convert numbers from an integer to a string and back again, which is very necessary when you're actually running this kind of code. So that's what this looks like.
Nothing fancy, but you could see how the input from a text box, being a string, is converted using the parse method to an integer. So we can do math on it. And once math was done on it, we converted the results to a string using the toString method so we could display the answer in a label. We didn't have to worry about how many bytes were being used. C# keeps all that hidden. We did have to concern ourselves about the size of the number being entered into the text boxes, however. The int data type limits us to a range somewhere between a negative 2 billion or so and a positive 2 billion or so. If we go beyond that, we'll generate an error. If we really need to work with numbers larger than that, we could use the long data type instead of the int. Now, this very same concept is used when it comes to other data types.
When we looked at integers before, we noticed that they all take 4 bytes. No matter how small the integer is, 1, 2, 3, 4, all the way up to 2 billion, it's going to take 4 bytes of data to actually hold that number in them. If you look at this chart right here, you can see how, hours work 40 is put in there and stored, and we're showing how it's stored in on the right hand side as well. You could define the variable first, then you can assign it the amount, or you can simply define it and assign it all in one fell swoop on the right hand side. Now, decimals are Not that different, except they need more space. If we look at a double, it's going to be able to hold a decimal piece of this thing. And you notice that the double right here, where we have double temperature being assigned to 87.6, it's using 8 bytes. Part of that is for the exponent, the 87, and the rest of it is used for the decimal piece. And there's a mathematical formula which translates all this. So we don't have to go into, we don't have to know, because parse and toString takes care of that for us. And if you look a little bit further on down the line, we have decimal, which is a much more precise form of keeping a decimal place in there. But it takes, as you can see, 16 bytes of memory to hold one single number. And again, it's split up into the exponent piece and into the decimal piece. And again, a formula is used to actually contain that amount into memory. So basically, this is what it looks like. So when you're dealing with variables, numeric variables, you're always going to input them as a string, as you can see on the left-hand side of this little chart here. If you're going to keep them as a string, like a zip code or a phone number, they just go to a string variable and stay out there. When they need them for output, they'll go to a label or whatever as a string output. No changes needed at all. But if you're using an integer or a double or a float or any other numeric type variable, you need to parse it. So it'll come in as a string in the text box. It'll be parsed into an integer variable that's going to hold it of those 4, 8, 16, 32 bytes of storage, whatever. And you'll use it there to do your math. Once that math is done, you'll then convert it back to a string, or at least the answer back to a string, so it can be put into a label or on a printer or whatever else, so the user can actually see what the answer turned out to be. And that's really the gist of it all. It's really not all that difficult. It looks a little confusing at first, but parse and toString are the way you convert back and forth from a numeric variable to a string variable.
So if you understand the concept of converting strings to integers, the process is virtually the same for all numeric data types. And we'll see that work as we learn how to do math in C# and, quite frankly, any other programming language. What you need to take out of this video is that, 1, an integer is always going to take up 4 bytes of memory. 2, the number of bytes needed to display that integer will vary. 3, you use the parse method to convert an integer to a string. 4, use the toString method to convert a string back to an integer or some other data type, a numeric data type. We'll see this all again in the next video when we learn how to do math and how to work with decimal numbers as well as integers in our programs. Thanks for watching. If you get a chance, please subscribe. We'll see you in the next video. Meanwhile, take care.